Hello students! Just a friendly reminder before we jump into this video to take out something to write with and something to write on and to jot down notes as we're going through the video so you have them to look back at when I ask you questions in class. The objective for this specific video is to discuss domain and range and then apply domain and range to the different types of function problems you will see. Before we can do anything, please jot down these definitions of what domain and range are, and I'm going to be talking about these throughout the rest of the video. So starting with domain, domain is just the set of all possible inputs. And when I say possible, I mean what can you plug into the function and get out a real solution. Okay, so what is it possible to plug in the function and get out a real solution? Okay, then the range is the set of all possible outputs. So whatever you plugged in, what are the possible things you could get out of the function machine or the function? Okay, and the reason I underline set here is because these are going to be written in set or interval notation, which is why we practice those at the beginning of the chapter. And I'll go into how you write them later on in the video. Let's start with this first function here. Okay, so I have f is equal to this set of points here. So remember, those brackets mean set notation. F is just the name of the function. Okay, so we are going to call this function f. Let's start with the domain of f. If I'm talking about the domain of f, I'm talking about what are my inputs in this function. This function is just a list of points, which means it's a list of some x and y values, okay, which you could plot on a coordinate plane. And if we're talking a function on a coordinate plane, my inputs is always my x value. Okay, then my outputs would always be my y value. Now, I want to write this as a set. I want to write my domain as a set. So I'm going to start with my set brackets. And all a set does is list out the members of a group. So for example, if you wanted to write the set of whole numbers, you would write something that looks like 1, 2, 3, on and on and on, and they'd be in your set brackets. Okay, just list out the members of that group. So what I'm going to do for my domain is list out the inputs, okay, the members of the input group. So inputs are x, so my x values can be -1, 3, and 8, and that is my whole domain. My range for this is going to be my y values, which are 6, 5, and 6. So right now I'm just listing what I see. But if you look at my range for this function, notice I'm repeating 6. And really, you don't need to repeat values in your range, because 6 is already included. You don't need to include it twice. So really, my range is just 5 and 6. My possible outputs are 5 and 6. You don't need to repeat. Let's go ahead and apply domain and range to this funky function graph over here. Starting with domain, remember that your domain is what you could input into a function. Okay, if we're talking about something on a coordinate plane, we're talking about our x values still. Okay, so when I'm looking at this picture, I'm asking myself, what x values are represented on this picture right here? Or what x values are used up? Okay, so I'm looking left and right and seeing what's on this graph. And I'll start with the left because whenever I listed my set or interval notation before, I typically wrote my lower bound first. Let's start with my lower bound on this graph. So here's my x values. Its graph starts somewhere around here. Now, as far as what's used up, I'm not really using anything past this line. Okay, if I draw vertical lines going this way, none of them will intersect with the graph because none of these really high negative numbers are on this graph. And the first negative number that is actually on this graph is this point right here. Okay, and if I figure out what that point is, this is 5, 6, 7. My first x value used here is that x is -7. Okay, that's my lower bound. Now notice this is an endpoint on the graph. So this function stops right here. Okay, it doesn't continue in this direction forever, ever. It's going to stop here, and that's my lowest x value used. There's nothing else left or right. Okay, now as I travel through the function, okay, all of these x values in between, all of these points are used up. Okay, so I could list -6.9, -5.25, -1.7523, and on and on and on. I could list all of these points are being used. So instead of listing my domain as a set right here where I list out all the elements, I want to rewrite this domain or not rewrite, but just write this domain in interval notation, because otherwise I'd have to list an infinite amount of points in my set. Okay, so my lower bound is going to be -7, and since this point is included in the function, I'm going to use my bracket. Okay, now we keep going on this function, we keep going through, and I'm getting to my positive x values. So which positive x values are used up on this graph? Okay, so I see that 5 is used right here, 6 is used, 7 is used, 8 used, so on and so forth. Notice there's an arrow at the end of this function, which means I could, in theory, extend this graph forever and ever and ever in the positive direction. Now, because of this, and this graph kept going and going forever, every single x value would be used. Okay, something like negative or positive 20 would be used out here. Positive 100 would be used all the way up here. Okay, since the graph goes on forever, that means my x's go on forever. So my upper bound then is going to go to infinity. And that's my upper bound. And instead of listing all those numbers again, I'm going to write this in my interval notation. So my final domain would be -7 to infinity. Okay, range is very similar, but we're talking about our y values. So I want to figure out what my lower bound is and what my upper bound is for my y values. Okay, what's the lowest y value I'm using, and what's the highest y value I'm using? Okay, let's start with the lowest, or the lower bound. Okay, what's the lowest point this graph goes to? So is there any y value that's, say, at -10 down here? No, there isn't. There's no red line that goes that low. Okay, the lowest point we see is this blue point here, which is where y is -1, 2, 3, 4, and 5. Okay, and that's included since it's part of the graph. Okay, the highest point, now if we're just looking up and down, this may look like my highest point, but remember, because there's an arrow here, this could be extended forever and ever going up. So what does forever and ever going up mean in terms of my range? It means that, let's see, +5 would be used in my graph, but so would +10. It'd be somewhere up here. And +100 would be somewhere off the graph out there. Okay, so all of my y values greater than -5 are going to be used. Okay, since this goes forever and ever up, my upper bound for my range is going to be infinity. Here's another picture of a graph. I'm not going to go over this, but you can pause the video and try this on your own. Remember, it's just a list of points. So it should be similar to something like the first problem we went over. What I want to hit on now is how to find domain and range when you're given an equation. These are the two questions I want you to ask yourself anytime you are working with an equation, because an equation is just a little bit more abstract than the graphs we were working with before. So if we're talking domain, I want you to ask yourself, is there anything x cannot be? And when I say cannot be, I mean when you plug in x, is there anything that would make your solution non-real? Okay, non-real is a no-go. Okay, x cannot be anything that would make your answer non-real. What I always like to do when I'm not sure what else to do is just kind of try some numbers. So let's say plug in something like 2 to this function. Is that going to work? Well, if you plug in 2, you're going to get 9. That's real, so that's okay. What if I plugged in something like -1? Well, if I plugged in -1, I'm going to get 6. That works. That's okay. What about square root 3? If I plug in square root 3 and square it, I'm going to get 3. Add 5, you get 8. That's okay too. So as you're kind of going through these examples, is there anything you cannot plug in for x? Or anything real that you can plug into x and not get a real solution? And the answer is no. No matter what you plug in for x, if you square it and it's real, it's going to be real in the end. So you can plug in anything for x. So our domain then is going to be, well, anything, which is just -infinity to infinity. The other way you could write this is just by using this R for the set of all real numbers. Okay, I'll take either form of domain, this one or this one. Okay, the range then, you're asking yourself, what is the lowest that y will ever be, and what is the highest that y will ever be? In order to figure out the range, I like to look at a graph. So I have my free online graphing calculator here. I already typed in y equals x squared plus 5, because that's the equation you're given here. And this is the picture you get. Okay, it's some sort of parabola. So the question is, what is the lowest y will ever be? So the lowest y point is 5 right here. And this parabola goes forever and ever and ever. It goes off the screen. It continues upwards in both directions. So the highest it's going to be is, well, it goes on forever. So it's going to go up to infinity. Since 5 is included and it's my lower bound, I will include a bracket. Infinity gets a parenthesis, and that's my range. You can always graph that by hand, or you can use your calculator. Next example, y equals 4 divided by x plus 3. Let's start with our domain again. Again, the domain is going to be whatever you can plug in for x. So I always like to ask myself, what can I not plug in? Okay, but sometimes before you ask yourself what you cannot plug in, I like to ask myself what I can plug in. So for an easier example, let's say you had the equation y equals x plus 3. What would be the domain for this line? And the answer is you could plug in anything for x and you'd be okay. So the standard domain for a line is just going to be negative infinity to infinity, okay, or all real numbers. So this problem is similar, except for the fact that x plus 3 is in the denominator. So while you may think you can plug in anything for x, there is some special number that you can never, ever divide by. And that number is 0. So the only thing you wouldn't be able to plug into this function is whatever makes this denominator equal to 0. Okay, you do not want that to happen. You cannot divide by 0. So what value would I plug in for x to make this denominator 0? Now you can solve this equation, subtract 3 from both sides, you get negative 3. You could have also just thought about this and said, what plus 3 gives you 0? That's negative 3. Okay, so your domain includes all real numbers because technically you can plug in anything for x except whatever makes the denominator 0 since this x is in the denominator. Okay, so the way I like to write this is it can be all real numbers with your restriction on x. So all real numbers, x cannot equal negative 3. You could also write this in interval notation from negative infinity to negative 3, and the union of that with negative 3 to infinity. Notice my negative 3 is not included. As far as the range goes, you want to know what the lowest that y will ever be is and what the highest that y will ever be is. Since at this point in your math careers, you may not know what this function looks like just by graphing by hand, I'm going to pull up my graphing calculator and kind of show you what's going on here. Okay, this is what my function looks like. I'm going to zoom out so you can kind of just observe what's going on at the ends here, at the y ends. Notice this function goes on forever and ever and ever. If you start from the right and continue around this loop, it's going to go up, it hits 100, it keeps going forever and ever. Okay, so it looks like our y is going to positive infinity. If you start from the left, it's going to continue on this function. It's going to go down forever and ever and ever. It looks like our y's are going in the negative infinity direction forever and ever also. Let's zoom in a little bit further so I get a better window. And notice what's going on right here. Okay, these functions are two pieces. They don't really touch. And if you look really closely at the x-axis here, you'll notice neither of these lines ever touch the x-axis, which means these functions, and I can kind of keep going here, and it's kind of hard to tell because I'm not zoomed in. Maybe I'll zoom in a little bit more. But these functions are actually never going to touch the x-axis. And you can look at this on your own graphing calculator by kind of changing the window and whatnot. Okay, so when I say it doesn't touch the x-axis, what is the y value at the x-axis? Because remember, when I'm dealing with range, I'm talking about what's going on with our y's. And if it never touches the x-axis, I'll go back to this, that means our range is never going to touch y equals 0. Because remember, the line y equals 0 is our x-axis, okay, because our y's are not going up or down at all when you're on the x-axis. So this graph is actually never going to touch y equals 0, ever. Okay, and you can look at that in your own graph. And if you think about the equation, is there anything you could plug in for x that would make your y equal 0? And the answer is no, because your numerator is 4. No matter what you plug in for x, you're never going to get 0. So we're going to have our range be all real numbers, except y cannot equal 0. It's really helpful to look at a picture. This might be a little bit abstract, but we can talk about this more in class. So please come with questions if anything was confusing. Practice more on your homework. Here's another problem I want you to think about. Think, what can you not plug into square roots? And we will chat more about functions in the future. Have a good night.